Hello, everybody, and welcome to our webinar this evening, at least this evening over here in Kansas. Welcome to 5 tips for selecting a drone for LiDAR systems. It's a webinar hosted by us here at Kansas State University and then our friends over at Modus Robotics. Just a heads up, this webinar is for anybody at the entry level of wanting to use drone LiDAR for mapping type applications. We hope to cover in this webinar the sort of information that will equip you with enough knowledge to where you can ask the right questions when you're wanting to approach whatever problem you have, and to ask the right questions to the different sensor manufacturers out there to make you an informed purchaser. Just a few housekeeping items. First, get familiar with this webinar interface. Zoom is a little bit different than some of the other webinar platforms out there. So I'd say just take some time in this intro to mess with the different viewing screens and the different functions. And specifically in this webinar, while Modus is delivering most of the content, we'll like to use the Q&A function. So find that button down at the bottom of your screen, or maybe at the top of your screen, and use that to ask your questions. And then we have a team here at K-State who's going to filter through those questions to kind of highlight some of those that we'll cover here in the webinar portion. And if we don't have enough time to get to all of them, we'll be sure to send out a full list answering those questions out to the whole group. So here to start out with, we're going to have a poll to kind of see what industry everybody else is involved in. So you should be seeing a poll up on your screen right now. We'll wait a little bit longer for some of those results to come in. There you go. There we go. And then there we'll kind of see the different results we have up. So it looks like 2 major distributions on surveying, and then a good broad category of other. So it's awesome. And then we'll go ahead and hit our second poll to ask what your role is in your current organization. Excellent. Thanks for those responses. It looks like there we got an even better kind of distribution, kind of all the way across the board. So we hope this will be a good and informative webinar for everybody, and you're able to walk away with a little bit more information than what you started with. So now we'll move on to kind of quickly, I'll tell you a little bit about myself. My name is Trevor Witt. I'm the UAS data analyst here at Kansas State University's Applied Aviation Research Center. I've spent about 5 years working in UAS remote sensing, focusing on application specific using technologies, mostly in the visual spectrum, but also done a decent amount of work in multispectral, hyperspectral, and thermal UAS remote sensing. Most of all that centers around structure from motion or photogrammetry type applications. So I'm really familiar with the capabilities and limitations of that technology. And then probably for a reason why a lot of you guys are joining us today, I started hearing more about LiDAR and what LiDAR could do and how LiDAR could benefit some of those use cases where structure for motion may fail. So that's what prompted a lot of this work today. And then a lot of these projects I've been involved with are about 50% in the agriculture spectrum. I worked about 3 years on a multinational project sponsored by the Australian CRC Biosecurity Research Institute. That was all focused on using unmanned aircraft for monitoring and detecting invasive insect species. We learned a lot with that project and a lot about the capabilities from when that started in 2013 to 2016. There was a lot of change in those years. Then about the other half of my work is related with utilities, electric, gas, primarily, and those projects tend in the more analytical machine learning realm, and then lots of other random ones. Being a part of a university, we get lots of different projects. Like from your screen, that you can see a nice aerial view of Kansas State University, shot with a converted near-infrared green and blue sensor. So those turf fields show out real nice and green, where all the actual live vegetation stays in that red band. So I thought we took that image, we did that mapping for a project we did with the Kansas Forest Service, looking at invasive bush honeysuckle in urban population centers. So lots of different work that I've been involved with. So then to give you a little bit of a brief history of the AARC here, we got our start back in 2008 because in 2007 we had a tornado wipe out the town of Greensburg, Kansas. At that time, Kansas didn't really have a good means of assessing damage from an aerial perspective. We would typically do that with Blackhawks through the National Guard, but at that time, most of them were deployed overseas. So with that lack of resource, the state recognized the utility of unmanned aircraft, and that's what prompted the start of the program. Over the years, we've expanded a lot into lots of different major milestones. From we're a major partner in the Assure Center of Excellence for FAA-sponsored research in unmanned aircraft. We've been a key player in one of the Pathfinder programs that the FAA sponsored the past couple of years. We're a part of the Pan-Pacific Test Range Complex, led by the University of Alaska. We're also a major player in the Integration Pilot Program, led by the Kansas Department of Transportation. But we're doing a lot of work with that. And then finally, we were recently awarded as the first university to receive a Beyond Line of Sight waiver for Part 107 operations. So lots of stuff going on through our center and also through K-State as a whole. So to give you a little bit more description on the Applied Aviation Research Center, we focus mostly on research, flight ops and training, and then maintenance and technology. Our research is on the remote sensing side of things, which I lead, and then also on the UAS operations. And then we also do a lot of professional education and outreach training, which you'll see at the end of this webinar, some extended opportunities to get some training through that. And then we also do a lot of integration of various different technologies into these platforms. And then also falling under our UAS program is the academic side. We offer 2 4-year bachelor's degrees, one in operations and one in engineering technology. And we also offer a minor in UAS operations to kind of cover and help all those students that are involved in these various industries that can benefit from unmanned aircraft. We've been able to see a lot of success from our graduates. Many of them go on to become government contractors. A large set are now entrepreneurs, leading their own companies, winning national competitions. And then a few of our other employees have gone on to some of these bigger name package delivery companies. So they're going out and doing great and big things. So next I'd like to introduce Daniel Hubert. He's our main presenter for today. Dan has been in the geospatial and aviation drone industry for over 25 years. Started out as a tactical imagery intelligence analyst, and then became an attack helicopter pilot and a Top Gun tactical flight instructor. Then he transitioned to command several Army Special Forces drone search and recon units throughout the Middle East. And finally, before starting Modus Robotics, Dan was a General Atomics program manager for the MQ-9 Reaper, specializing on flight and sensor tactics training. Dan routinely also consults for companies like Nokia, Intel, PwC, and others on the drone sensor and data strategies. He stood up Modus Robotics to assist small companies with drone remote sensing technologies and data management that is rapidly changing today's industries. He employs ex-military drone professionals and NGA geospatial college master instructors to take the knowledge learned over the last 15 years on the battlefield and bring it to the industry for good. Recently, Modus launched LiDAR University, a site specifically designed to help companies understand and adopt drone and mobile-based LiDAR collection strategies, which that will be a key asset for those that find after this webinar that they can really use this technology for their needs. And also, who will be chiming in and helping us out is Dennis Davison with Modus Robotics. Dennis has over 25 years of experience in the naval intelligence and geospatial realm. He's worked with the 3-star admiral staff, worked with the Pentagon and the Joint Chiefs of Staff. And then recently, before Modus Robotics, he was at the NGA Geospatial College. And while at Modus Robotics now, he leads their data training and data analysis side of things. So with that all said, I'll transition the control over to Dan, and he'll kick off to the main event.
Excellent. Thank you for that introduction. And give me 1 second while we switch screens here. Okay. Trevor, can you see my screen?
See it.
Outstanding. Okay, let's roll. All right. Well, thank you for that introduction, and welcome to my half of the webinar. So it will be me and Dennis going through. Dennis is going to keep me honest because I get very, very excited, and so I tend to talk very quickly as we go through this stuff. Let's cover a little bit of admin before we move forward. These slides are going to be they're going to be very full. There's a lot of information that we're going to pack into them. So as we're talking about working with your interface there, if you can minimize my picture and Trevor's picture, that way you'll see the fullness of the screen. If you want to see me, that's great, but yeah, you might miss out on some of the information that's packed into these slides. So with that said, a little bit about Modus. Yes, we're enabling small companies in the geospatial remote sensing for drones. Primarily right now, what we're focused on most is LiDAR. And so we do a consultant-based type of sales network where, I work with companies on best strategies. I look at different use cases, whether they're doing feature extraction or they're doing geographic topography or a varied things. And then I do a lot of QC of a lot of different technologies out there to see if they're actually going to be satisfactory. Being that I came from General Atomics, what we see in the small drone market versus what we see in the large drone market is that a lot of the small drones, they're rapidly deployed, they're rapidly in design, where if I'm taking a Predator or a Global Hawk or something like that, there is a lot of type certification that goes with that to make sure everything is to spec and it's going to work. And that typically is not what you're seeing in the small UAS. So that's why I'm in this space, is to kind of take all that stuff that we've developed 10, 15 years ago, put it into the small UAS and let you guys succeed and make money. And that's really what we're about. In addition, we do sell hardware. So I am a LiDAR broker, not a manufacturer. And I represent several companies and I'm able to make offers based on the individual use cases that people present to me. So I've done a lot of the work. I've been doing this kind of field study for over 1.5 years. as I've gone through this. And lastly, I have a whole team of either former NGA or USGS analysts that work with us. That's where Dennis came from. They work out of the Geospatial College and also as regular analysts. And so you'll see, like as we have LiDAR USA or LiDAR University stood up, you're going to start to see more of that where, yeah, we do LiDAR, we do regular photogrammetry, but we also do hyperspectral, multispectral, and even in some cases, we do synthetic aperture radar. So that's the full gamut of what Modus Robotics does. Okay, so what we're going to cover today is 5 tips or 5 secrets on how to select a drone LiDAR system. So this is the LiDAR head, the GNS INS solution that's behind it. I'm not going to really talk about the drone in specific, but you'll get the gist because the drone, believe it or not, is relatively irrelevant. And then we're going to talk, about different strategies as we go through. The layout for these slides is I'm going to talk in very general terms first, so they make sure everybody has a baseline of what I'm referring to. And then I'll get into the specifics about the different component or the different capability that we're going to be working with today. Okay, with nothing ado, I'm going to move on. If my slides will move. There we go. Okay, so first I'm going to start off with a big broad view talking about market uncertainty. And since everybody here that I've seen in the surveys, by the way, thank you for that, says they're in surveying, which is a lot of my customer base, I'm going to direct this webinar more towards topography and that kind of discipline versus feature extraction and building modeling and that kind of thing. So that way you'll get more out of this content. So when we look at LiDAR, LiDAR has been around for a long time, and so we have different ways of implementing it. The first way, everyone's pretty familiar that we have satellite. And what we want to lay out here is when you want to use these different types if you have access to them. So with satellite, whether you're using Landsat, Planet Labs, or one of the databases, the advantage is that this satellite is it's very broad extent. It covers a wide amount of area. Cost per area is not too bad. The quality level that we get out of there, depending on which satellite and its orbit, you can still get a quality level 1, but you're not going to get much more than that. And then part of that resolution problem is the Earth is covered by 80% clouds, just like same thing with visual type technologies. So having those opportunities where you're not obscured by atmospheric conditions that cause scatter become a problem. And then of course we have accuracy that you have to go through great means to baseline and make sure that you're geodetically sound. And of course speed, like we were talking about, depending on how many orbits you have, or the periodicity, or even just trying to get that, it can be rather difficult if you don't know where you're going. Then we have traditional aerial, which also has been around for quite some time. Again, covers a wide amount of area. It is still the gold standard out there. Obviously the cost per area is a little bit pricey, and when you're dealing with those kind of services, getting the flight clearances, making sure that you have the right environmental conditions and all that, doesn't really lend to it being at your fingertips at any given point in time. However, you're dealing with larger sensors, better IMU systems, so the accuracy and the resolution are pretty good depending on how many control points and what geospatial standard they're upholding to. Then we have the traditional survey, which you all are familiar with, and we'll talk more about that piece, but since I'm dealing mostly with surveyors, I'd say by far the biggest attribute and the place that I love you guys is really in your sound on making sure that your credentials and the data that you put out is accurate, and that's why you have that credential. So then we get into this area here, the unknown, which is the drone, and in there we can kind of break in on other webinars that I do. I talk about terrestrial scanners and mobile scanners, as well as the UAS or small drone. But the big thing here is we look at these others, there's a place for it and there's a place not to use it. And so what we're going to go through today is, now how much area you can cover is a broad topic, which we'll actually be giving another webinar in September on that. Your cost per area is really good, because you have that, it's truck equipment, it's survey equipment, it goes with you. So having that access and that ability to have your data when you need to makes that very, very affordable. Again, resolution is outstanding, and we'll talk a lot about resolution to the point that you can almost have too much. And so in the geospatial world, you can actually collect too much data for topography and that kind of stuff. And we'll talk about where you want to look at that and why you'd want to look at high resolution versus low resolution. And depending if you want to do aspect with a drone, because you can vary altitudes, your resolution isn't just from the top. You can get side scan capabilities, which will not be on par with a terrestrial scanner because their resolution and the ability to sit there for long periods of time is much better. But if you're doing a mid-grade side scan, you're going to get low centimeter resolution. I left accuracy as a question mark because this is what most surveyors have the question. Is it how sound is it? How reliable is it? Is it close to the datum? So I'm going to talk a lot about this as one of the decision points. And the speed, I can't tell you that we can cover a lot of area, and since it's all digital, we have a slide just strictly on speed. So, okay, so the first area that I want to talk about is resolution. And there's a lot of misconceptions. So when I designed this slide, what I'm going to really talk about is the difference, and I'm going to talk a little bit more in the next slide or 2 slides down, of what resolution is, or relative accuracy versus absolute accuracy. A lot of folks get that confused. There's a lot of marketing campaigns out there where they're claiming horizontals, they're not claiming verticals. They're not actually tying it to georeference points. So, when we talk about resolution, what I really want to talk about is, where it actually is sitting in reference to itself. And the major consideration is strictly inside the LiDAR head. So this is a specific item in a spec sheet that you're going to see. And so when you're looking at, let's say, a Velodyne, or you're looking at a Regal system, and they're quoting these accuracies are relative, because you're going to need an IMS or a GNS and an IMS to actually give that absolute accuracy, which we'll talk about in a minute. But the other thing that's not commonly understood about these is beam divergence. And if you look here on your left and right-hand side over here, what we're trying to illustrate here is all light diffuses or diverges. That's why we call it beam divergence. And so the farther away your target is, the larger your spot size is going to be. The reason why we use lasers is it doesn't diverge as much. But when we're dealing with these smaller drone sensors, you're not dealing with the types of optics that you're going to do with like an aviation model. And the heads are going to be a little bit different. There's still some really good heads out there that are going to give you survey grade material, but you just have to be aware that your point density or your point spacing or your spot size is going to change, and that's going to vary what results you're going to get. How's that? Is that better? Okay, thank you for that. All right, so with that, I'm going to go into, so the tip today, as I'm going to talk about, is make sure you look at that spec sheet, and you're going to see, they're going to give you different accuracies, if it's a good sensor head, at different spacings, 50 meters, 100 meters, 300 meters, and so forth, and that's important. So based on what application that you need, and how you're going to be operating, your resolution is going to be important. And so I'm going to show you a quick comparison here. So we have a Regal UX1 UAS over here on the left-hand side. and we have a VLP 16 on the right-hand side. Altitudes are about the same, and the speed of capture is about the same. Now, what you're seeing here, there's a couple things at play that are going to affect this as well. But you can clearly see here that the resolution from the Regal product is much better. And you can direct to, like, for instance, I'm going to pick out over to the left here, we have forest, and you pick out the trees, the undercast, and the individual structures. Now, granted, this is 3D visualization data, so we can change the alias or the point sizing, but we've kept the alias for both these data sets the same. And so you can see over here on the right-hand side with the VLP product that you don't quite have the same resolution and the same the breakout. Now, is that important? Well, that really depends on what application that you're doing. I mean, the price point between these two is 10 times the scale. So, if your customer is going to pay for high resolution or they need that, and there's cases like, environmental studies, when you're doing vegetation studies, here for the power, you've got the slackline measurements and you've got, change detection for the different structures. So there's a lot of things that you need that kind of resolution to get change detection and microtopography, especially if you're going to layer your data sets. On the other hand here for the VLP, we're still getting roughly the same amount of point density per meter squared. But if you're doing topography or you're doing, open area vegetation management, you can still get a lot of data out of this. And that's why most people actually still buy a Velodyne because it's affordable and you're still getting great data. So it really, when I sit down with a customer and I'm having this discussion, I'm really going into what their specific data needs and what they're going to generate as a product to get into judging which product makes the most sense. All right. Okay. Let's see if I'll pull it a little farther away. Okay. How's that? Okay. So the next one is accuracy. And in this intro slide, we're going to talk a little bit about the different types. And I had to bring in classification accuracy as one of the others. So the one area that everybody gets confused is, when they talk about accuracy, they talk about it as accuracy. And that's not necessarily right. So like when we were talking about relative accuracy, that is the integrity of your structure or your point cloud or the polymesh product that you're going to make from that. So you can measure it in your X, Y, and Z, but it has no geospatial reference whatsoever. And so for the folks that are dealing with photogrammetry, as a good example, your first initial product when you take it out of processing is a relative point cloud. And it's not until you actually sync with your ground control points that you're able to actually snap it into a coordinate system and then test the individual points to see if it matches your benchmarks. Okay, well, our absolute accuracy, on the other hand, is just that. And since I'm dealing with surveyors, I know you guys get it, is, when you set up your control points, how far is the deviation? How many points you're going to need. Everything's measured in root mean squared or your 95% error. So there is very strict standards, whether you're just following surveying standards or you're following FEMA standards, which we'll talk about here in a minute, or we're talking about USGS or even ASPERS. But for the folks that aren't aware, that type of accuracy, it's checked against a known point, and it's only done in the vertical axes because if you were to try to match your X, your Y, and your Z, it's too complicated. And if your Z axis is off, your Y and your X axis will also be off. So for the gold standard, when we talk about accuracy, it's going to be your vertical. Now I put classification accuracy on here because that's that next step, and with that, it's just a reference point. If your relative and your absolute accuracy is off, your classification accuracy is going to go. The better your data comes out from a geospatial point of view, the better classification accuracy you're going to have, because when you take it through the algorithms that you're going to be matching, I wouldn't say with a level 1 classification scheme, but when you start adding different types of vegetation, when you start to add different types of structure, and you get into those higher schemes, you're going to have a series of filters that's going to actually try to help identify. If you don't have good accuracy, you're going to spend a lot of your time in quality control on the backside, checking to see if your classification scheme held solid through your production. And for those that aren't aware, how you do that is you're going to have a series of also classification checkpoints, depending on how big your size is. Depending what your classification scheme is, maybe about 5 to 10 per classification type, so that you can match and go, okay, yes, this is a building, or yes, this is a certain type of low-grade vegetation versus a tree canopy. You're going to match those, and you'll take a side profile, you may take an over profile, or you may actually use orthographic data to tell you what that is. But that's going to show up in your classification reports, or your accuracy reports. Okay, next slide, if I can get there. Okay, so the next part of why accuracy actually matters is the level of geospatial correction. And so when you're dealing with your accuracy, the first part of the story, like we were talking about before, was the laser and how it hits the ground and where that sits. But the second part of that is now your GNSS and your INS solution. And for those that aren't aware, I'm going to kind of go through the levels of options that are germanely offered on most products today. So in the first one we have is the autonomous, and that is just straight GPS receiver. You have it on your cell phone. It's not accurate. And so depending on who your vendor is, they may offer you just an autonomous GPS option. And then maybe, depending on what their scheme is, they may add packages onto that. So for folks that do know, you definitely are not going to do autonomous. But if you don't, make sure that you're looking at what those packages are, because it's just another way they do things. But you can see here in this example, this is Velodyne 16 data, and we had 8.2 meters of absolute error there. Now with the same data set, you can come into satellite-based augmentation. So in the US, that's UAS, wide area augmentation. If you're in Europe, there's I forgot off the top of my head. And then you have them in India. You also have them in China, and then you have your select services as well. And what that does is it adds that relative error, or subtracts that relative error from the motion of the constellation. And so what you can see here on this example, we're down to 2.6 feet of absolute error. So now those individual points, there's less. We've eliminated some of that error, not only from where that point size is, but now where it actually is sitting on the Earth's surface from an XY point of view. So it actually enhances your resolution in addition to your absolute accuracy. And then the last bit, and the last real option that you have, is differential GPS correction. And again, for those that aren't really familiar, we have real-time kinematic correction, which what you have now, you still have satellite-based augmentation systems, but you're now adding another layer in real time of a base station with a telemetry or a radio unit. And so it's getting its GPS coordinates, and hopefully it's better than your drones. It better be. And then you have your drones is receiving it, and then your processing unit on the drone is making those corrections and comparing those two in real time. So there we're seeing, usually I'm in centimeters, about 8, maybe 7 centimeters of absolute accuracy in real time if you're using that scheme. There's a lot of vendors that offer that, and if you need it really, really quick, like right after you land, and then obviously real-time kinematic is going to be what you're going to want. But there's very few applications that I know of right now that you need that data right now. Like for instance, if you're using volumetrics, you're probably going to use photogrammetry unless you're doing really large data sets and you need it in a mining type of operation or something like that. A lot of people or a lot of vendors use it because they have real-time streaming. Real-time streaming is where they're sending down the point cloud data. They're actually sending it in parse. So it's not the full cloud, but it's good as a quality control tool, but really won't be good as a production tool. So, it's like I said, it's good to say, hey, do I have holidays or shadows in my data set? So I tend to veer customers away from real-time kinematic unless they have a really good user case. And the last one I have here is post-kinematic. And so that scheme still have a base station, and it's still setting up its geodetic information, and the drone has its. But typically after you land, you'll send your base station data into cores. You'll get it corrected to the Earth's surface, and then you'll fuse them together. In this particular example, we did post-kinematic, and we had a little over 4 centimeters or 0.13 feet of absolute error, and you can see the resolution difference. And by and large, that's usually what I recommend at the end of your data processing. All right. So the last little bit with accuracy is really more getting into the real system now that you know why that's important. And that really has to do with the IMU. So the GPS part of that is pretty germane. Some systems have dual, which they do a little bit of heading correction. So like SBG Systems has a dual. I think it's the Ellipse 2. So I think BOE Systems has that. But you also have single systems that work just fine. A lot of the reason why you'd have dual is to remove having the need to have like a fiber optic gyro and that additional weight. But it really depends on what kind of equipment you're having. So when you're talking to your vendor or you're reviewing a system that you're going to go contract with, really what you want to look at is on an IMU is its response time. How quickly is it sampling, and then what kind of heading resolution are you getting? Because when you go into some of our other webinars and we talk about flying, heading discipline is going to make or break a good drone LiDAR collection. And that has to do with just the characteristics of the IMU and how that actually operates. So what I typically see is, someone will buy a brand new unit and they'll fly it by hand, and they won't really have good heading control, and they wonder why they're spraying the ground. They're seeing these little ripples in their data sets, and it all has to do largely with the IMU not being able to catch up with the heading hold equations when they're figuring out the inertial drifts that they have. Pitch is okay, altitude change is okay, but heading hold seems to be the big thing that you need to look for. The last thing to look for is depending on the quality of IMU that is being vended. You're going to go through on the ground what we call a coarse calibration, where you're getting your heading set up in the right direction. And then a lot of systems require a fine calibration where they need to fly to fine tune. So it's about 2 minutes of either figure eights or cardinal changes. And that tells you that IMU, it doesn't have a good sampling speed. So there's a few out there that don't need that, and we recommend that. But again, it comes down to dollar point and where you want to enter the market. Okay. So the next part here we're going to talk about is point density and point clouds. And so for a lot of folks, and I was actually amazed sitting in, I think it was a PwC contract that I was working on. I was sitting with a bunch of GIS professionals, and they didn't really understand what they were looking at and what point cloud data was. It was these three-dimensional colored pictures is what they called them. And so I want to kind of spell out what point data is, why it's important, and then get into the collection aspects for your system. So by and large, what LiDAR data really is very discrete points inside a data table. I know it's very exciting stuff. So it's going to have your X, your Y, and your Z at a minimum. And so that's going to give you your point. Now for systems that like a Velodyne or a Regal, depending on what you're going to be using, you're going to be collecting somewhere between 200,000 to upwards around 700,000, maybe even if you have dual return type of options, up into the millions per second. Each one of those points is going to have a it's going to have your three cardinals, so your X, your Y, your Z. It will probably have your return depending on which LAS scheme you're using, and I usually talk about that in another session. You're going to have an intensity level, so it tells you what kind of reflectivity that you have. It will tell you the characteristics of your heading, so what pitch, roll, and yaw that you actually had in there, your scan angle, your time that it actually happened. So that's a lot of data per second that actually is happening there. And that's why LiDAR data is so flexible, because you can strip stuff out of it. If you get the wrong bore site, you can actually go through running an algorithm and correct it. But what you're looking at in point cloud data is a slew of discrete points that are fused together. So it's vastly different than what you see like in photogrammetry. All right, so how much do you need? And this is where I spend a lot of time consulting. It's like, well, I need as many points as I can get my hands on. And the question is, especially if we're going to gear toward topography, how many points do you really need to get a 2-foot contour or a 3-foot contour standard? Not that many. So why would you spend hundreds of thousands of dollars to have in this particular case, 1,500 with a Regal VUX1, when a BLP 16 would achieve the same results for your topography. So again, knowing those data standards are really, really important, and we'll go over a little bit more of that in detail. But the biggest thing is not to over collect, because if you over collect, then you're going to spend a lot more money in labor costs and processing cost on the backside, down sampling your data sets and tiling them into smaller chunks, which with drone data, since you're covering small areas, you shouldn't have to. But if you're going to be collecting such large volumes like this, you'll run into those schemes that you typically see in aerial type collections or projects. So the real question is to ask yourself is, how much do I need? If I'm doing topography, how many points do I really need versus if I'm going to be doing structural modeling or some geomorphology or watching a dam move or something like that, where now you need to have a different scale than you would if you're doing just contours. Okay, and so the last part of point density is what standard are you going to base it on? And so we're, I think tomorrow we'll have it up, but in LiDAR University, we have started to compile, different geospatial remote sensing standards, whether it's ASPERS or USGS or FEMA. I think we have a few others. And if you're into building information management, if you're talking about level of design and how many points you need if you're going to do that kind of modeling, and if you're doing transportation, what DOT standard are you using? Because they all pretty much outline, what point densities you need, what kind of quality assurance you need on your data sets. And if you're over collecting on that, then you're actually slowing down your process, which we'll talk about here in a few minutes. The other piece of that is, as we talked about, what's your software? What's it actually going to handle? What density does it need to do feature extraction? Like if you're using, I'm looking for one right now, Blue Marble versus for utilities, PLEC CAD, how many points do you need and how tightly do you need to pack those to actually pull out feature resolution? So it's picking the right software in your workflow is also part of your point density, which moves me into the, the measurement requirements. The amount of point density that you need is also how you're going to pull that out. So if you don't have points on an object, you can't measure it. However, when we talk about that, it also is largely based on reflectivity. So, bare earth, I may be pulling 350 points per meter squared, which is really good. But now if I get into vegetation, I'm down to 70 points per meter squared or 35 points per meter squared, depending on canopy. And if I'm trying to do limb size versus, let's say, a cable, a 3 centimeter limb will have the same reflectivity as a 1 centimeter cable. So, again, it comes down to what's your application to get the results that you need. We already talked about reflectivity. All right, and the last piece of this, and this is, two different schemes that are going on in the LiDAR world. We have Regal that sends out a signal and can get multiple returns based by multi-sampling the same data stream that comes back. So it's a slightly better receiver. Where Velodyne, which was originally an auto sensor, and uses a first and last scheme, and some people use just a single pulse. And so it depends on, again, that application that you're going to be doing, whether you just need the top layer, which is a digital surface map. If you need to do a DEM, which is a digital elevation map, where you want to pull the surface off and just see the bare earth readings. Or if you really want to get into canopy and feature, you get multiple returns. So if you remember the first example I showed with the Regal and the Velodyne, part of what you were seeing in that model, in addition to resolution, was you were getting more return. And so therefore you were seeing more under the canopy in the Regal. And again, it really depends on the application that you're going to be doing. I will put a little tip in here, and that is that, depending on the manufacturer and who they cater, is kind of how they do their spec sheet. So if you're dealing with somebody that's dealing with surveyors, they're really good at actually underestimating accuracy and underestimating density, and then surprising you. And they're also going to be very accurate in stating, hey, this is the amount of energy that's leaving, not necessarily the promised returns of what you're going to be getting. If you're dealing with other sensor operators, they think that that standard should be the number of returns. So they double their numbers or triple their numbers depending on the amount of returns that they're capable of receiving. But you really need to look at the amount of energy that they're putting out, whether it's the amount of frequencies or the number of pulses, discrete pulses, depending on what their LiDAR head methodology is. And that's going to tell you what your maximum, your optimum point density is going to be. And then after that, your terrain is going to dictate what you're going to get back. Okay. All right. I'm going to move a little bit faster now. But another aspect that's really good to talk about and as a selection criteria is your collection height. And so just quickly, we got some pilots in the room. We've got some surveyors. We may have some commercial pilots in here, but when we talk about altitudes, they're not all the same. So when we look at this example here, we have on the left-hand side, you have, ATO, which is your altitude above takeoff. A lot of drones report that. And so it can be very misleading, especially if you're taking off from a high area and then you're going low. Now you're dealing with negative altitudes. And so what is right? And for me, as being a regular pilot, that's pretty scary because I don't know what my separation is with the Earth's surface. Next one is the altitude above ground level, and that, so if you're using like a radar altimeter or a sonic measuring device, or some form of GPS that has already integrated in the terrain, that's a little bit more reassuring. This is typically what I use, because a lot of what I'm collecting is map of the Earth. And the last method is mean sea level, which is a barometric standard. Don't ever use that. Just don't. But I need to mention that these are these different standards out there that you need to consider. And so if you're Part 107, you should know this, but for the folks that aren't aware, this is important. And the AGL is what we're going to base all of these calculations on for your density. So your point density is, is a function of two things. And that's going to be the function of how fast you go over the Earth's surface and what altitude. Because remember, we talked about having beam divergence. Well, you're dissipating more energy the higher you go. And you're not going to lay as many stitches across the faster that you go. So those are the two elements that are going to affect your point density over terrain. So depending on what your point density requirement is one aspect. But the next part is your height and your speed, particularly your height. Reason being is depending on where you're operating inside the United States, like if you're here in the southwest part of the United States, we're bare, we're desert, we can be 20 meters off the ground, it's fantastic. You go up to the northeast or the northwest, now you have tree canopies, you can't see that far, and you don't know, or you have to guess on what the tree heights are going to be, 180 feet, 200 feet, and then you have to map on top of that. So, understanding that piece of it is the first part. The second part is altitude, is efficiency. So going to the next slide here, when we're actually doing, so light photogrammetry, you're going to have a footprint below you. And that footprint is going to dictate how much area you're covering in the tide. So what you need to do, or how you need to figure that, typically I use a field of view of 90 degrees, unless I'm getting into more advanced stuff. And what that allows me to go is some very, very simple math, that my altitude is going to be 2 times my swath, or my altitude times 2 is going to be my swath width. So if I'm at 100 feet, my swath width is going to be 200 feet. And then I take 10% off for overlap. And, a lot of vendors will say, hey, this is my max altitude. Well, that's not exactly right. You're, like we talked about with beam divergence, you're going to have different capabilities at different altitude schemes. And also it's really about max slant range. So how far away you can actually see, period. So that when you're looking at this little triangle here before you, the distance that matters is the diagonal to the ground in your field of view. My personal preference is I set filters so that I don't see anything in the blue example here, so that I don't get any noise in my solution. Some people turn it on and they just filter down the backside. But the most important thing is to understand where your field of view is and how much area you're covering, because this translates to efficiency. And the most expensive thing in the field is your field time, with people, labor, travel, and all that. So you want to minimize how much time you're in the field, or you want to maximize how much area you're going to cover. So again, when they talk about max altitude, what you're really talking about is max slant range, and then start to do the quick calculation there for 45 to figure out, what that slant range is and how much of a swath you can cover. And we covered that in our class in great detail, because it really is important. Also with collection, why does this matter? So we kind of alluded to this already. It really is about coverage area efficiency. And so we have this illustration here talking about low altitude versus high altitude. And yeah, it really is to scale. I'm just kidding. But what you can see, depending, and by the way, either one of these is totally acceptable depending on the use case that you need. But you may want to fly lower, if you need higher point density, or you want to get more feature extraction. Right now we're showing this as shadow, but if I was to move that drone off to the side, I would start pulling out feature extraction of the buildings and those materials that are out there. However, for the surveyors out there, and you're just doing straight topography and terrain, then you want to be higher, and you want to cover more area quickly, because again, time is money, and the more hectares that you can cover, or the more of a geo corridor that you can cover, the better your pricing, the better your return on investment. So again, height matters for 2 things. One is your coverage area, which I think, again, we'll have a webinar in September on that. And then point density, optimization on, what height do I need to go and what speed do I need to go to pull out the features that I need for my software to process and deliver an outstanding product. Okay. Okay, workflow. This is pretty important. And what wasn't mentioned is I actually am a Lean Six Sigma geek. Navy put me through it, and I've been paying the price for it for years now. You know, and people don't realize in aviation, we do a lot of process improvement. You know, everything that we do in a cockpit or in maintenance is very lean, you know, partly because the decisions that we have to make, but also, you know, time is money. And so we do a lot of process improvement. So I've kind of had to wear that hat for the last 10 years. And that's part of how I do some of our consulting, because I look at what exists. So what you're looking at here is an example, at least the top 2 rows here, when we talk about conventional surveying workflow and photogrammetry, is based off of Burns and McCormick's study last year, along with 3D robotics, talking about how they did regular survey points of a water feature dike, you know, climbing all over the rocks and doing their surveying lines, and then putting it into taking their the radio base stations and actually loading that in. And they illustrated that process and how long it actually took them. So it was a pretty solid report on how they did that. And then at the same time, they did a photogrammic workflow where they were flying drones. They didn't really get into camera settings and visibility and all that. But from a time and workflow standpoint, it was a pretty compelling argument. And the accuracies were very comparable, especially with all the control points. So it makes a very strong case to use drones. Now, what we're going to add on to that example is, you know, what I see on a typical day when I'm using LiDAR. And I've actually kind of been very conservative with the numbers that I deal with. But typically, let's say I'm doing 15 acres. A really good example, I was doing a couple months ago, I did a rock quarry. I was using just a VLP-16 and a DJI 16 drone. I cleared 15 acres in 22 minutes. It took me 30 minutes to set up, get my base station and all that running. With breakdown time, you know, I had the data downloaded 30 minutes later, and had my first 3-dimensional point cloud or visualization for check, really 30 minutes after landing, or if not less. And I had a PPK solution or a full refined solution 4 hours, within 4 hours from start to finish. So that was my workflow to get to visualization. And after that, then I hand it off to the analyst who's going to take it through and do surface modeling and accuracy analysis and all that. So that's just one very small work case with 15 acres. Oh, and by the way, the terrain difference on there was 300 feet across. So it was a rock quarry and we didn't stop. I mean, we went straight up the hillside using automation. It was pretty good. So if you're using these from a work point standpoint, you can get a lot of efficiency. You know, and when we teach automation, and we cover not just how to program it into the computer, but what are those safety profiles that you need to consider so that you're operating safely, you're not going to lose any equipment, you're lowering your risk and liability. But if you do those things, again, LiDAR is great. You know, and I've got guys that are going out there right now and they're paying off their equipment in less than 6 months. So it's very compelling, you know, even though the equipment is more expensive than photogrammetry, the workflow, you know, and what you're getting in the term of measurement is phenomenal. And I just kind of threw in the bottom just to kind of talk about, you know, because this is kind of a photogrammetry versus LiDAR slide, even though it's really not meant to be. If you do need colorized data and you're doing dual sample, you can do a draping, you know, and that will get you your visualization data. So it's still a little faster than photogrammetry. But if you're trying to get RGB clouds, you know, do photogrammetry in addition to. Okay. So, but workflow in general, now that we understand that, I want to break down into, you know, when we ever do a project, is what's the basic process you're going to be doing, you know. And so in drones, you know, you're going to have an order and a planning session, which is very specific to how your company runs, and then you're going to have collection, you know, whether so how you're going to do your field survey, how you're going to set up, and how you're going to actually fly the drone. You know, and there's tons of information on that, and we teach that, and so does Kansas State. But then what I really want to focus on from a selection standpoint is the workflow for LiDAR processing. And So what you should be looking at, and when you're talking to, somebody that's doing a service, what we're really looking for is ease of use and data check. Okay, so how accurate you have. And so as I've surveyed all these different systems, some folks are like, hey, we just shove it all in there and this is what we get. And other folks are very, very precise on making sure that they have the right state datum or whatever datum they're using, and that's easy to use. It's very clear that how they do their geocorrection, and what standards they're using there. And part of drones is the inertial collection, and how clear. I mean, are you using loose couple? Are you using tight couple? How resolute are you filling in the gaps between your GPS fixes? Then you have your LiDAR compiling. How smooth is that? Are you clicking in a bunch of points? Because a lot of early adoption software we saw, you had to actually add the points in or the timestamps to get your swaths. Or do you have a visual representation that allows you to hook it? And I would say that, in the ideal case, when you're compiling your point cloud data, which is a combination of your geospatial, your correction, and your LiDAR data, the best thing to have is a little bit of both. And the reason being is occasionally the drone will pitch because it's doing wave 2 points, and you're going to want to filter those ripples out. But by and large, if your drone's running smooth, you're going to have good data and you can hook. Because you don't want to spend a lot of time, especially in the field when you're checking your data to see if it's good, so you can leave the site. And the last part of your process should be control points. You should have software in there so when you set your control points, you can find them both in tabular data of where you've actually set your points. And if you've used the right targets, you should be able to see your LiDAR data and have tools to find that exact center so that that you're spot on your data reports. So I'll leave that saying, hey, really look at how they flow through a problem and see if this actually matches what your workflow and what your culture does and integrates in with your flow. And the last part I'm going to leave as a tip is when you look at those data samples, if they're starting to look fuzzy, there's probably something either wrong with the equipment or the software. So really work with your sales rep to figure out what that is and look at multiple data samples because that's usually an indication of a software issue. Okay, so hey, I'm going to leave you with a quick bonus. Even though we said 5, I really kind of have to throw this in because we've spent really a year and a half looking at the small drone, small LiDAR market. And there's some really great products and there's some really, really smart people out there. So I'm not going to say this one's good and that one's bad. But what I will say is, regardless, this is an emerging technology. And, there's still in the small UAS world, unlike where I came from, there's still a lot of unknowns and there's a lot of development still happening. And so if you choose a technology that may be not fully baked, this is probably the number one thing you need to look at is their customer service. Because, even a year and a half ago when I was looking and adopting and helping some of these LiDAR companies out, the thing that sometimes things did not work depending on who the vendors were. And it was how they responded that made the difference. So when you're getting a quote or you're dealing with a problem or you have a question, how fast are they responsive to you? That's going to tell you after you purchase what kind of support you're going to get. The next thing is when you ask those questions, what's their level of expertise? Are they are they MIT scientists that work in a laboratory and they're really good at making stuff? Or do they really understand surveying, GIS, and what those applications are for? Because you can have folks that make great equipment, but then aren't usable to you in the field. And so I would say that more than anything, I wouldn't let price dictate as much as service, because there's some really affordable LiDAR on the market, and you're going to get what you pay for, where it's still in prototype and they're trying to make a stance. And at the same time, there's some very expensive LiDAR out there. And believe it or not, their service is also bad. But in the middle, there's a lot of good companies out there. But I would really look at what they're putting in, what they're bundling, and how fast they're going to be responsive to your specific customer needs. So that's just my experience, and just kind of as a gift to you. I will probably pay for that if somebody talks to me, and you guys will take me through the ringer, but it's important, and I want you guys to succeed. And so you just make sure that that whoever you buy that from or service from is responsive to you. Okay. So, I want to conclude here really quickly. Part of this is an introductory. So if you liked what you saw here today, this is very high level of what we cover in a 3-day immersion course. And so, we've partnered with Kansas State. I think in this particular case, for what we have up here on the screen, we're going to be showcasing BOE systems. I will also be bringing a Regal system so that you can see what the 2 different data sets look like. But this is a time, if a lot of times you'll talk to a vendor, and this is what got us into this, and you can't make any sense of what they're talking about. The technology is new. It's a drone. LiDAR does not work the same way as photogrammetry, so your results is very varied. And so what we found is that we had to keep on doing demonstrations, and demonstrations, we charge about $8,000 per day for those, because we're traveling and it's not cheap. And if you go to like someone like Regal, they're doing $10,000 for a full-on demonstration and take you through their data pack. But in addition, what is unique about this is, in addition to telling you about LiDAR, which you can read up on, and showing you how to fly it, which is important, because if you can see different ways and you can say, hey, I know this is going to work for me, or I know that it's not, or this is a technology that I want to contract out, and so now I understand what's all involved, so I'm not getting taken to the cleaners. The other thing that's part of this is we have our NGA instructors, and that day 3 is so valuable, because in addition to showing you how to plan these out and get perfect LiDAR data and optimized data and making those decisions, and getting into the field and setting it up and figuring out what that all entails, is what products you're going to get out of the backside of it. How easy is that going to be, what workflow looks like, and is that something that you can actually deliver for your customer? So unfortunately, we've already fully closed out August due to a lot of things, but we have October open. So if this is something that you like, or something that you want to explore, we've given Kansas State some very special pricing. Normally I charge $2,000 per seat, and I know it's not, but it's 3 days of intensive learning. So if you want to see, the different, where all the different sites are that we currently are holding, you can check on LiDAR University at live events, and they'll map that out. But if you want to see Kansas State's full training suite, whether it's their Part 107 or their photogramming data course, or our LiDAR course, or their night course, they've got a lot of good stuff there as well. And so you can find that at Kansas State Fly with the Experts training. And I think you guys will be very, very impressed with that as well. That's why we partnered with Kansas State. So with that, Trevor, I think I'd like to hand that back over to you. And if there's any questions, I would love to see if I can answer those.
Yeah, absolutely. And thanks, Dan. That was very informative. And even me, after doing probably the past year, I've done lots of research on it, and I feel like I learn something new every time I talk with you. So it's great.
It's you need to be quiet, right?
But I like what you have to say about customer service, because I experienced the same thing with the hyperspectral sensor that I was working with. And it's also a very relatively expensive sensor package, but that company is so responsive. Every time I have a question, and even going there and getting some training, hearing stories about having a customer on a sat phone and teaching them how to work through their problems there in real time, it was really amazing through that company. So yeah, customer service is key to
Absolutely.
sort of systems. And then to also pitch with our partnership with you for this 3-day LiDAR course in October. During day 2, us at K-State, we have kind of a special access to this area called Crisis City Training Center. It's a location run by the state of Kansas that has a simulated train derailment and rubble pile, a rescue tower. So even in that small little city block kind of a size area, we're going to be able to collect lots of good different sample data sets for our course attendees who want to see what this technology can do in various different terrain environments. So I think that's one of the special things. We're not just mapping a grass field.
No, you're going to be blown away with what this stuff can do and what we're going to do with it. I'm excited about that site.
No, absolutely. So I'm looking at my team right now, and we don't currently have any Q&A questions.
Wow.
I think you laid it all out there.
Well, if they do have questions, let's give them an email address, whether it's yours or mine, and I'm happy to answer after the fact, because there will be questions. I'd be surprised if there wasn't.
Yep. Yep. And then we can switch over to our screen,
Okay.
which will show, I think.
Somebody said, I need to follow up about training.
There we go. So yeah, here's a little bit more laid out from that our website that Dan shared earlier. We got multiple different course offerings. Our by far our most popular is the FAA Part 107 or SUAS Commercial Training Course. That's a 3-day course. We've had nearly 150 people attend that with a 99% pass rate. Kind of demographics that we usually see, about a third of those are first responders, and about a quarter come from the agriculture industry. So it's fun. We've been able to train a lot of people and get a lot of people up and going. Some of them choose to go on to take some of our multi-rotor trainings and specific law enforcement training, which was started because of that high percentage of first responders taking our course. And then there, of course, we've got our LiDAR course that's going to be there in October. And then also there's a course that I teach that focuses on the photogrammetry side of things, what you can do with just a visual imager or multispectral type of imagers, and using structure for motion techniques to make maps and point clouds. That's another 3-day course that's structured much the same way. The first day is classroom, second day is all practical demonstration, hands-on work, and then the third day is all data processing and analysis. So double check and make sure we haven't had any other Q&A questions come through.
We did have one, if we're going to post the video and post, and I know we'll have it up on the LiDAR University site, you know, and I think you're going to post it up on the Kansas site. So if you go to lidaruniversity.com, probably by next week, we'll have the video up so that you can have those notes along with, I'll probably also put the slides up if you guys want the slides as well. I'll put that in as one of the deliverables underneath that. So you can take that, and if you want to share that with other folks, I'm more than happy.
Dan, you mentioned LiDAR USA.
No, not at all. LiDAR USA is one of the folks that we vend along with BOE Systems and Regal Direct. But yeah, I all the time go with LiDAR USA versus LiDAR University. But LiDAR University is mine, and Jeff Begerman's company, LiDAR USA, is one of the ones that we do work with.
I would like to ask about the slide concerning RTK versus PBK.
Sure.
You're saying PBK is for actors.
Yes, I am. Yeah. For what, when we do our clouds and we actually take it against, you know, about 6 to 10 ground control points, that I am seeing RTK as not as accurate on our LiDAR systems, on LiDAR systems of the same IMU. So, resolution or accuracy will change from system to system. And again, that's why I say go through, make sure you get data sets, make sure you get control points, and you get accuracy studies. But from what I'm seeing overall, when we're dealing with LiDAR data, I'm seeing PPK is much more accurate. Now, I am aware that in the drone community, when do you want RDK versus PPK? And RDK, at least for when I map it out, RDK is essential when you need to have really strict control of your drone and where it is geospatially, especially if you're around structures and power lines and that kind of stuff. And so it kind of gets mixed that you need it in your data sets, where PPK is for that post-processing. It's for the data that you have. So I'm sure there'll be some people refuting, but again, when you talk to your vendor, pull out the data sets.
Are you using post-pack for the inertial device?
Post-pack, I'm not even aware. Next one.
Starting with B.
Okay.
Planix software.
Planix is a Trimble bot company, and that's one of the several that you can use.
Cool.
Okay.
I think, yeah, that's giving people a good amount of time to be able to put in their questions. And yeah, like Dan said, this webinar recording will be pushed out to everybody in an email, along with all the different resources and contact information for you to be able to reach out to us. Which will also be nice, because I know from a lot of the participants who signed up for this course, had quite a bit of international people that sent us an email and said, hey, it's going to be 2:00 in the morning. Is it going to be recorded? And yeah, it definitely is. So yeah, I don't have anything else on my end.
Well, thank you everybody that had attended, and like I said, catch the video, catch the other resources we provide you, and hopefully we'll see you in one of the other later webinars.
And hopefully we see you in October.
Absolutely.
Awesome. We'll see you later, everybody.
Thanks, everyone.
Thank you.